Hey y'all, this is Dr. Suddath. I would be right now taking you for a walk out in the woods on campus, but since we can't do that, today I'm going to tell you some stuff about plants here in my neighborhood. I'm in a little park in my neighborhood and I'm going to just walk around and show you some different plants. So here we are in a little stream, and I've come to this little stream to look for our seedless plants, because if you remember, because the seedless plants don't have pollen, they have to be in a wet place in order for the sperm to swim to the egg. And so here we are looking for seedless plants, and there are so many. Down here you can see some moss. We've got a few different kinds of mosses along here. And so mosses are our seedless non-vascular plants. In addition to not having seeds and pollens, they don't even have the ability to transport their own water. And so they're living here right at the edge of the stream or in a shady place in your yard where they're nice and wet, so that nutrients can be transported through their body without the need for their own vascular system. We also have here some ferns. These are our seedless vascular plants. Here's one example of a fern, and there are a few others around here I'll show you in a second. The ferns now have the ability to transport water up through their bodies, so in general they don't have to live in a wet place, except that they don't have the ability, again, for their sperm to get to their eggs anyway, but swimming. And so at least during part of the year, their habitat has to be wet so that their sperm can swim to the eggs and make babies. Another thing to notice as I show you these is to remember that in the mosses, the gametophyte that makes the eggs and the sperm, that's this main thing that you're seeing here, the green stuff that's fuzzy and everywhere. Hopefully we'll also see some sporophytes. They're the part that grows up from the gametophyte, but is supported physically by the gametophyte. The sporophyte is not green, it can't do photosynthesis. All it does is make spores that can then fly off through the air. In contrast, our ferns have separate sporophytes and gametophytes. The plant that you see most of the time is the sporophyte of the ferns, and the spores are released from time to time from the back of the ferns. We'll look and see if we can see any of the sori where the spores come from. The gametophytes are a separate plant that you can sometimes see at the base or near the base of the sporophyte, and we'll look for some of those too. So those are a few ferns and sporophytes, ferns and mosses. Here's a different kind of fern here, and we'll see a few more ferns as we walk along. Oh, these have sori on them. Let's go look at the sori. I'm crossing over the stream here. So if you look at the back of this fern, if I can get it to focus, you can clearly see those little brown spots. Those are the sori. That's where the spores are released from this fern. So that's our seedless plants, both vascular and non-vascular. The next group we're going to talk about are the gymnosperms. Gymnosperms are those naked seed plants. They are seed plants, they are vascular plants, but they do not have flowers and they do not have fruit. That's how they're different from the angiosperms. And here in Georgia, the most common gymnosperms that we see are conifers. And here you're looking at some pine trees, are very common conifers here. And remember that in the seed plants, the plant that you see all the time, that's the sporophyte. And we'll talk in a minute about where the gametophytes are. So here you see a cone, which is where the name conifer comes from. This cone is a mature female cone from a pine tree, and those pointy things that you see, those are the seeds of the pine tree. This is a very recently mature cone. It's just fallen off the tree, so the seeds haven't been released yet. A lot of times when you find a cone on the ground, the seeds are already gone, and it's just sort of a shell of where the seeds used to be. Up here, you're seeing the immature female cones of a pine tree, and also the male cones. The male cones would contain the pollen where the male gametophyte is, and the pollen would blow through the air. It's not transported by animals, it's blown through the air and land on an immature cone on another pine tree where the sperm would then swim through the cone and reach the egg inside the cone made by the female gametophyte inside the cone. And here you can see some immature female cones on this tree. So gymnosperms, pollen transported by the wind, no flowers, no animals transported pollen, and there's no fruit. They're just cones, male and female. Some other gymnosperms in the world that we don't really see as much around here are things like the neophytes, the ginkgos, which you might have some ginkgo biloba in your yard if people planted them, and the cycads, which are look sort of like palm trees. You might have one in your house as an ornamental plant. The last group of plants we're going to talk about are the angiosperms. Those are our flowering plants that have fruit, and this is of course a great time of year to talk about flowering plants because they are flowering. Here in Georgia and really throughout the modern world, angiosperms are the most common and diverse group of plants. First, we're going to talk about monocots. Here you have a great example of a very common monocot. All of the things that you think of as grasses are monocots. And the way you can tell this is a monocot, if you look at the veins on these leaves, you can see the veins all run parallel to each other. There's no spreading mesh network of veins, they're just parallel. If you happen to find a monocot that's flowering, like a daffodil, a lily, something like that, you'll notice that it has petals of the flower and other parts of the flower too, if you look really close, in multiples of 3. So 3 petals, 3 stamen, 6 petals, 6 stamen, 9, 12, and that's how you can tell. In general, the monocots grow low to the ground and they don't create a true vascular cambium, so they can't make something like a trunk. However, in Georgia, we do have one fairly common monocot that gets bigger than that. This is our saw palmetto. It is native to the coastal plain, but you can find them growing wild here in the Piedmont, like I just did. And so if you look at the saw palmetto, you can again see the parallel veins on its leaves, but you often see them growing with a trunk. This is a small one, but you can look here at this trunk and see that it's not really a trunk like a big tree we're going to see in a second. Instead, it's made up of the remainder of last year's leaves that are slowly falling off and building up and up and up, and that's how these grow as a monocot tree. The last group we're going to talk about is the other major group of angiosperms, the eudicots. And you can see here a flowering eudicot tree. Here in Georgia, most of our big trees that aren't conifers are eudicots, and that you can already see the distinction between them and the monocots in that they have a vascular cambium and can grow these big trunks. Down here, when we look at what makes them eudicots, how you can tell them from monocots, looking at this leaf, you can see instead of having just single parallel veins, like the monocot did, it has a mesh of veins. And if you look at this flower, if you count the petals, this little flower has 5 petals, and if you could see the other parts, they would come in 5s. In general, eudicot flowers come in parts of 4 or 5. Eudicots also are the ones that make most of the fruits that we're used to eating, the tree fruits and the berries. I hope that was a useful introduction to the diversity of the plants in your own neighborhood, and that you go outside soon and look for the same thing, working hard to complete your digital organism collection. We'll do this again next week to look at fungi.